Hello, let's continue our Sudoku adventure with Yin-Yang Something Something by Sanabas. And yes, Sanabas has been on a Yin-Yang kick, so we're going to be getting a lot of Yin-Yangs. But that is fine, they're pretty fun. So we do have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Now we're going to be shading some cells. This is the Yin-Yang. Yin-Yang is its own pencil puzzle, and Sanabas has integrated it into this Sudoku. So by tradition, shaded cells are going to be a gray color of some kind. I'm going to use this light gray just because you can see things behind it. And if we've determined a cell is unshaded, I'm going to use green, which when you solve digitally. So if you think about on paper, you would just use a pencil and shade in that cell. That's why it would look gray. And we're just going to use green, which with digital solving tends to be the color of choice for not shaded, just to give us a nice little reminder that we've proven that one's not shaded. Now, what we need to do is we need to shade some cells, but not all of them, such that all of the shaded cells are orthogonally connected to each other. Orthogonal is just sharing an edge. So these are all orthogonally connected. I can't just do like a little blob over here and say, I'm done because this is not connected to that. Even if we went diagonally like this, you cannot connect diagonally. You would have to, finish with connecting with edges. In addition to that, all of the unshaded cells are also all orthogonally connected. So that would be true of this grid currently. But if we did something like this, then now we have unshaded cells down here, which are not orthogonally connected to the unshaded cells up here. So that would not be allowed. In addition to that, no 2x2 area is fully shaded or fully unshaded. So this would not be allowed because that's fully unshaded. If I shade this here, this would not be allowed because that's fully shaded. You need at least one shaded and one unshaded in every 2x2 area. And that those do overlap. It's not just like splitting it up like this. You have to consider this 2x2 and this 2x2. All right, and so that is yin-yang. Now, we are told that all of the given digits are shaded. So these two cells are just given as shaded. That gets us started. You need some starting way of determining what's shaded and unshaded. Otherwise, you could swap the two. And so we need to have some way to define what's a shaded cell, what's an unshaded cell. Now, we have these blue lines in the grid. These are not region sum lines. These are just sum lines. On a blue line, the sum of the shaded cells is equal to the sum of the unshaded cells. So let's just use this one here. If these two were shaded and this one was unshaded, the sum of these two equals the sum of this one. Even if we did something like this, the sum of these two is equal to this one. So this could be like 2 and 3 and 5. 2 plus 3 is 5. That works. And that is it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so I'm going to immediately go over 2 tips for yin-yang that anyone who solves yin-yang should learn immediately before they even solve their first puzzle. First thing is, there is no way to do a checkerboard without breaking connectivity. If we try to do a checkerboard where we have 2 diagonals that are unshaded, 2 diagonals that are shaded like that, then what happens is we need to connect the shadeds to other shadeds in some way. And when we do that, we're going to end up having to loop around this unshaded cell or this one, isolating it from the rest of the unshadeds. These two can't connect. And if we try to connect to the unshadeds, we have the same problem with the shadeds. So since we need full connectivity, no checkerboard. That's actually pretty common in shading puzzles that need full connectivity. So in addition to no 2x2 being fully filled, we also can't checkerboard them. In addition to that, we have a border. You can figure out this border thing where we only ever have one block of shaded and one block of unshaded. So there's 2 transitions only. That's because if we tried to make, say, these 2 shaded, we need to connect these shadeds to the shaded somewhere, to the other shadeds on the border, right? In some way. And that's very similar to the checkerboard where we end up with isolated unshadeds when we try to do that. If we try to do it like this way, we're cutting through everything, right? We're creating a border that the unshadeds can't cross. So those are 2 deductions that are probably going to be useful in every yin-yang. All right, we're going to start with these 2 being shaded. Now, these 2 can't add to 2 because we can't do 1 and 1 in the same column. So one of these is shaded and one is unshaded. I don't know which is which though. Let's see. So this line here, remember that we can't change more than twice, right? We need a singular block. So we have this line that's fully on the edge and this line that's fully on the edge. But we know that every line has at least one shaded and one unshaded because we need to be able to add to each other. So we can't fully shade this, meaning at some point we are going to transition between shaded and unshaded. And so the shaded could be, it feels like the shade is going to be on this side, right? Because this will just connect there. Now, technically, we could do something like this if we're just considering this line and then unshade these. But the issue is that fully shades this line here. So we are going to have the 2 come to here at least. Now, we can't have 4 digits add to 1 digit because 1, 2, 3, 4 adds to a minimum of 10. Or 1, 2, 3, 4 is 10, meaning our minimum sum would be 10 here. So we need to shade at least one more. And now these are 3 to 2. That works just fine. We can have 3 add to 2. So we don't know exactly where this border is going to happen. But what we do know is that this is going to have to extend all the way around here and at least shade this one in order for this to have one of each, because we can't make a pocket of shaded in between 2 unshadeds, as described earlier. And so now, again, 4 can't add to 1, so we're going to go at least one more here. Now, there's 2 reasons this needs to be unshaded. One is because of the line. Second is because we can't make a 2 by 2. This unshaded is going to have to connect to everything else, so it's going to escape up to here. Here we can't make a 2 by 2, so this is unshaded. And now we know these can't both be unshaded, because if they were, they'd have to be 1 plus 1 adding to 2. So this is shaded. This has to get out. Don't make a checkerboard, so this one's shaded. If this was unshaded, we'd make a checkerboard, which is no good. So that one's shaded. And now we can't do 4 to 1, so we know these are both unshaded, which at least goes to here and then to here, because again, 4 can't add to 1. So this is in contention, but we're not sure. Don't make a 2 by 2, so this is shaded. Do we need to start doing numbers here? So this is 3 digits that can't repeat because of the box, adding to a single digit. So this is going to have to be a 1-3 pair adding to 6, for what it's worth. That means we know what this sums to. This is a 4-5 pair, so I'm doing 9. We know that this has a 2 and a 6, and then a 1 or a 3. We know this. So there's probably more shading I can do, but I want to think about this for a second, because I think this will tell us whether this can be shaded or not. So if this was shaded, then we would add to 10, and these 2 would need to add to 10, and the only way to add to 10 is 6, 4. Or it would add to 12, and that's way too high. No 2 cells can't add to 12. So there's no way this is shaded, because the only viable option would be to sum to 10 with 1, 4, 5, but this can't sum to 10. So this is unshaded, and they're going to add to 9. They must use the 6, and they must use the 2, which is already 8, so they have to use the 1 with it. And so this is the 1, this is the 3. Right? And so then this is 3, 4, 5. Okay. Got some numbers. I bet I can shade more. Yeah, this is unshaded because we can't make a 2 by 2. And so now this line, I don't know, actually. This could get out through here or through here. This line is one of each, which is interesting. It's the same digit. It's cloned. One's shaded, one's unshaded. Are there any connectivity issues to speak of? Or, I mean, this comes through here or here. That's the connectivity. I wonder if I can get more digits. I wonder if that would help. So whatever this is has to be 2 larger than whatever this is, because this plus 2 equals that. So the options are 3, 4, 5, 6, I suppose. If this was 1, 2, 3, 4, it's not that exciting. Do I think about this one? These 3 add to these 2. I'm not sure. Seems pretty open to me. What am I missing then? This guy? I don't think so. There must be more shading to do. there any dangers of 2x2s? Any dangers of checkerboards? Not that I'm seeing. This is going to connect down to this guy somehow. Okay, so remember I said this gets out through here or this gets out through here. It's going to have to, it means this guy's green. Because if this guy were shaded, then this is now isolated. It's a wall there. So this is green, meaning this is unshaded, meaning this is shaded. They're the same digit as each other. Does that, I mean, we need to avoid a checkerboard. So we need to avoid, well, no, this won't be a checkerboard. Never mind. Now this is going to have to get out. So it either goes left or it goes up. And so this is one of each. One is unshaded, so the unshadeds get out, and one is shaded, so the shadeds get out. Does that mean anything to me? This is gonna, okay, these, this either connects down here and comes through here, or it connects to this guy and comes down. Oh, these have to, if these connect, they could connect through here, but do we always have to come through here? I don't think so. This could come down. Okay. Well, no, hold on. I was reading this wrong. Okay. Huh. I'm just not seeing how to continue here. Is there a line that's particularly restricted? These just aren't two. It's not exciting. I don't know. Is it this one? This is one of each. Or, oh no, I guess they could both be shaded. There's at least one shaded on here, I guess is the conclusion. Not exciting. What's going on? Is there a line I'm ignoring? Is it this line still? These two sum to these three. That doesn't seem that exciting. Is there a minimum for this guy? This could be 1, 2, 3, I'm pretty sure. Adding to 6. So like, this is minimum 1. We could do 1, 5. Well, no, because, okay, if this, okay, so actually there's an issue here, which is that we can't repeat digits. So maybe that's the key. Maybe these are more restricted than I thought, 3 adding to 2, because we can't repeat any digits. So we're certainly not doing 1, 2, 3 here, because that would be 6, and without 1, 2, or 3, we can't add to 6. 4, 5 would be our minimum of 9. So, okay, well, so the first conclusion is that the sum of this and this, so basically every line, the sum of all the digits on the line is going to be even, because it's going to be twice whatever the individual shaded and unshadeds add to. And so if this adds to an even number, we know an entire column adds to 21. 1 through 6 is 21, which is an odd number. So in order for even plus this to be odd, this has to be an odd number. So the only available digit is 1, and that makes that 6 and that 2. So this isn't 2, meaning this isn't 4. Now, that means 1 is missing, so we know what these add to. These add to 10. So in order for 2 digits to add to 10, this has to be 4, 6. Those aren't 4s. And then this is just going to be 2, 3, 5. All right, and the 2 goes there. All right, that's what I was missing. I probably could have done a similar analysis here. Although this was 1 or 3, so maybe not. Okay. Well, I got there. It took me a bit to remember that that was a thing we could do. Anyway, that's 6, that's 4. These two digits are a 1, 4 pair, so this is the 1, this is the 4. Okay. So we got digits. This is 3 or 5. Wondering about this line now. So if this was unshaded, we'd have a problem because then this would be shaded and have to be at least 7. So this is always going to be shaded. And that tells us this is unshaded, so the unshadeds get out. Now this whole blob could get out a few ways. So if this is shaded and it's 3 or 5, what are our options here? These are 1, 3, 5. So could this be a 1? Yes, if it was unshaded, it could be 1 and this would be 5. Or if it was shaded, this could be 3 and that would add to 4. So this is 1, 3, 5 because it's a clone of this one. So what's missing? The 6 is placed in the row right here. Okay. So this can't be shaded because it would mean 6 plus something equals this guy. So it has to be unshaded. And these two add to 6, either 1, 5 or 2, 4. Can't be 2, 4 because the 2 and 4 are gone. In fact, this is only from 1, 3, 5. So we're going to be 1, 5 adding to 6. That makes this a 3 and that a 3, and that's a 5. Making that a 1, which means it has to be unshaded for the line to work. That's 5 and that's 3. That's 1 and that's 5. That's a 4 and a 5. Okay. What's this going to be? Well, these unshadeds have to get out, so I'm assuming what's going to happen is this ends up shaded, so that this has to be unshaded for it to get out, but we'll see. Well, this we don't want this to be stuck. Anyway, let's just look at what's left here. We need a 2, 3, so this is the 3, this is the 2. So this cannot be shaded, or we'd have 3 plus something equals 2. So this is unshaded. So maybe I was wrong. Anyway, that's a 1. We get the 5 and the 3 here. This pair is a 4, 6. So this is the 4, this is the 6, and then down here we need the 5. The column finishes with a 2. And then let's finish our shading first. Yeah, this has to get out, so this is going to be shaded. And it is a 4, and we're done. Nice. All right, yeah, I think this would have been smoother if I had thought more about this instead of immediately rejecting that it had a useful sum. But yeah, the fact that it used 5 out of 6 cells from the column meant thinking about the outie was extremely powerful. And then once we identified the outie, we were able to determine what the individual sums had to be. Neat. Very cool puzzle, Sanabas. These Yin-Yangs have been fun. Hopefully we don't tire of them. But yeah, how'd you do?